Hello and welcome to Build Your Own CPU Part 6. In this episode we'll be looking at this test box. I built this to test each card individually. Across the top here we've got 8 switches. They can be switched as they are at the moment to make the 8 signals inputs, or if they're switched into the up position we get a 1 coming out, and if it's down position we get a 0 coming out. When there's supply on the box, these LEDs will actually light up to let you know that. And when it's in the middle, if the signal's coming in, again it will light the LED. These down here are just 4 momentarily push buttons. So you press that, and while you're holding it down, you've got a signal out. As soon as you release, it comes off. These LEDs will light up as well to let you know that you're pressing down successfully. So let's have a look at the circuit diagram to this before we take it apart and look to see what's inside. Now this is the circuit diagram for the 8 switches and the 8 LEDs at the top. So if we zoom in on just one of the circuits, a bit too far there, you can see we've got a supply coming in the top, feeds down to the switch, no volts at the bottom also feeds up to the switch. The supply also comes across through this resistor onto the LED that is switched via this MOSFET. This is all to stop it from loading up the circuit on the input. So this pin here is the input and output, depending on the position of this switch. As we've got it at the moment, we've got 5 volts coming through the switch, through a current limiting resistor in case something goes wrong, and then feeds as an output. So we'll now be feeding a logic 1 out, which is 5 volts. It will also feed onto the gate of this MOSFET and turn it on and light the LED. Now if we move the switch down into the bottom position, we'll have 0 volts on the switch, 0 volts coming through here, pulling this signal here down to 0 volts. Thus we've got a 0 going out. And as we've got 0 volts on the gate of the MOSFET, that will turn off and turn the LED off. Now it doesn't show it on this diagram, but this switch is actually a 3-position one, and it can switch into the middle. And when it's switched into the middle, this is all becomes floating. It's not connected to the positive or the negative. It's just floating. So this pin now becomes an input. So any voltage applied on the input here comes through onto the gate of the MOSFET, and if it's high enough, it will switch the MOSFET on and turn the LED on. So we can measure a logic 1 and 0 coming in as well. Now the push buttons, there isn't actually on this diagram for the bottom 4. They just supply this voltage through a resistor like this straight to the output. It also feeds the LEDs, so those 4 are just basically outputs, they're not inputs at all. The idea of the switches is you can do like a momentary pulse signal, like you can simulate the pulse signal to the cards or the clock signal or anything you want temporarily on, so you can do multiple tests in one go without rewiring the whole thing. So if we now have a look at the actual circuit board, that's here. So this is all 8 switches again. We just zoom in on one of them. So we've got the 5 volt supply at the top, 0 volts at the bottom, and these 3 pads here go to the switch. So 5 volts to the switch, 0 volts to the switch, and the signal coming back in. So we'll either be switching 5 volts through that 1K resistor to the gate of the MOSFET for the LED, and that's the actual output, that pin. Or if the switch is in this position, you'd be putting 0 volts onto there, so we get 0 volts going out. Then when the switch is in the middle, then this is all floating and doing nothing, and it's just the input here feeds direct onto the gate of the MOSFET. There's your 82K resistor input impedance. Then you can switch your MOSFET on, turn your LED on. So there's just 8 of those. I didn't get this board made, I made this on my small CNC mill I've got. You just feed the Gerber files to it and it'll cut it all out and drill the holes for you. It takes about an hour, but it's quicker and easier than doing a photo etch. And it was just a one-off for this test box anyhow. So here we have the actual test box. It's ribbon cable coming out here. It's got multiple connections, you can see them clearly. You've just got pins on the ends that you can stick into the end of circuit boards. If you've got a circuit board like this, you can just poke them into the holes. Let's get one in there so you can see. Another one. And what I did, oh, I just snapped one off. A bit fragile. They just sort of just hold them at an angle while you got the board going and you're testing it, or use a bit of blue tack or something to hold them in place. No, don't focus up close. Just DuPont connectors, ones with a little pin sticking out the end. Get that in the board. So if we open this up, so there's a little cover at the back here. It's just a box, spare box I had in my bits and pieces. So the connector cable here is actually plugged in on a little daughter board in there. And so when these break up and they're not good enough anymore, I can replace the cable quite easily. And quickly was this open. It's not my best soldering in the world, but it did the job. And the last one. Pull that out of the way. Now I can lift the cover off. So, there's my pencil. A little bit. So here we have the circuit board sitting at the bottom. With the LEDs on the other side because they're standing proud. In fact, it's the LEDs that hold the board in place. So you've got your MOSFET and resistors, etc. So most of the wiring's on the other side. So to cut down on the wiring, it looks as if you've got the 3 pins here for your 0 volts switch signal and your 5 volts. So 5 volts comes in here, but that does change down all of them. So it's only wired in one position. So that's your switch connection there, and there's another one there, and so forth through the others. They'll feed up to these switches here, which is got up, middle and down. And what I've actually done along the switches, instead of running separate wires for all of them, I've got this wire daisy chained all the way along the back. There's another one down the other side. So 0 volts one side, 5 volts the other. And they'll be feed straight across over to this little daughter board at the end. It's just a bit of aero board. But, so there'll be a 5 volts coming in on, I believe it's on the black and white wires here. And that just feeds out to these rails. And these are the push buttons up here. So the push button just has a resistors feeding the LEDs. So as I say, it's all a bit of a tangle of wires. And these range wires here with joins in, because these wires are only about that long. I've got thousands of them. They're ideal for these jumper links. I bought a load of these years ago, solid core. So you can do your little test boards, jumping across, etc. So I use those wires just because I've got so many of them. And these weren't long enough, so I just joined them together. So all just crams in there. And so they all individually feed across this variable that just goes straight across a strip with, you can see there with a light on it, and these little push pins. They can just push the wire, push the wire on and off. So if the ribbon cable breaks or whatever, you break the pins at the end, it can be easily replaced. Oh, what you'd do is you'd have, say, put these 3 or 4 as the input. Say those 2 would be going into the adder A register and those 2 into the B. And then these ones you'd leave as inputs and they'll be feeding out from the adder. So you can put any numbers, or you can put some numbers in here and make sure your adder's edging out correctly. Do it 2 bits at a time. And if you want to test like registers, you could put these as like, put the number into the register. And then you'd have one of these as that wire to the register select. And then this one would be like pulse, to pulse it into the register. Each of the register cards has got its own LEDs and that, so you can actually see whether the data went in or not. Oh, where are we? You get hold of the interlead here. These two, black and white one, they're the supply. So I just put 2 pins like that, because most of the boards have got a supply coming at the top and feeding out the bottom. So when I've got it on the test rig, I put a supply on the top from the bench power supply, and this I just push into the bottom and get it going. Hold it in there, so I've now got a supply to the board, and then these outputs can actually be switched, and they'll be switched to whatever inputs or outputs you want. I'll go through this board on another video. That's basically it. But it enables you to test every piece before you put it together. As you can see, it was very worn. I shall be actually building this board in a later episode and using this box to test it, to show how it all works. This is a demultiplexer, so we'll have 2 bits in and 4 bits out, and going out through buses, etc. But we'll go into that detail later. And then you can see exactly what all these switches and lights do. I think that's enough for this video, and hopefully I'll see you in part 7.